Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating analysis of the Okta Bcrypt incident and what it reveals about API design. The core issue, a vulnerability stemming from how long usernames were handled in conjunction with Bcrypt's hashing limitations. It's a wild ride.
Right. I'm eager to hear this. The Okta incident was a big deal, but what exactly went wrong? Was it just a simple oversight?
Not quite a simple oversight, but more a cascading failure of several factors. The problem stemmed from concatenating user IDs, usernames, and passwords before Bcrypt hashing. Bcrypt has a 72-character limit. If the combined string exceeded that, characters were silently truncated, leading to a weakened hash. Imagine the implications.
So longer usernames essentially made passwords easier to guess? Because part of the password was ignored?
Precisely. A username exceeding 52 characters rendered the password effectively irrelevant. Even shorter usernames significantly reduced the brute force effort needed to crack the hash. The author, N0RDY, highlights this with the example of Albus Percival Wulfric Brian Dumbledore. A rather long email address. Yikes.
That's alarming. So the core problem wasn't Bcrypt itself, but how Okta implemented it. A lack of input validation?
Exactly. The Bcrypt algorithm itself has a known 72-character limit. The issue was the lack of input validation in Okta's API. A simple length check could have prevented this entire debacle. And Zero Reedy's blog post meticulously tests several popular libraries in different languages: Go, Java, JavaScript, Python, and Rust, to demonstrate this point. It's a compelling case study.
And what did those tests reveal? Did any of the libraries handle the input validation correctly?
The Go implementation, and a specific Java library by Patrick Favre, included built-in input validation, throwing errors for inputs exceeding the 72-character limit. However, other widely used libraries, like Spring Security's Bcrypt implementation and the popular JavaScript Bcrypt.js library, lacked this crucial check. They silently truncated the input, mirroring Okta's flawed approach. A concerning trend.
So the problem wasn't unique to Okta. It's a widespread issue in how Bcrypt is implemented in various libraries. That's a serious vulnerability.
Absolutely. Then Zero Surety's analysis highlights the importance of robust input validation, especially in security-sensitive contexts. The blog post even delves into the history of the Bcrypt implementation in OpenBSD, tracing the truncation behavior back decades. It's a reminder that even long-standing practices need revisiting and improvement. A fascinating historical perspective.
So what are the key takeaways for API designers? What should they learn from this?
Several key lessons emerge. First, don't let users use your API incorrectly. Explicitly reject invalid input. Second, be predictable. Avoid surprising behavior. Third, no ego. Acknowledge limitations and be open to feedback. Fourth, be helpful. Design APIs that guide users towards correct usage, especially in security-sensitive areas. And finally, be brave. Don't be afraid to deviate from established but flawed practices. And, of course, reiterate. Regularly review and update your API design.
It's a powerful message. This isn't just about Bcrypt, it's about responsible API design in general. Thanks for breaking this down for us.
My pleasure. And remember, listeners, stay tuned to Tech Bytes and News for more insightful discussions on the latest tech trends. Have a great day, and goodbye.
Bye-bye.